Lab 1, Logic Gates. The purpose of this lab is become familiar with the basic logic gates, verify the operation of logic gates, take a real-world problem, and create a digital circuit. Learn how to use a tool for digital logic simulation. As part of the lab, we practice filling out three tables like AND and NOR gates. In the AND table, the only case where A and B is true is when all the inputs are true. The OR gate, the output is true whenever any of its inputs are true. NAND and NOR gates. NAND gates means NAND OR. This table, output OR, is the inverse of the true table for our OR gate. So it is a gate output is false whenever its inputs are true. NOR gates means NOT OR. Is the inverse of an OR gate. It is a gate whose output is false when any of its inputs are true. Finally, XOR gate, or exclusive OR gate. This gate, none of the inputs must be true, although both, for the output to be true.
A laptop microprocessor is to have a circuit built into it which will sound an alarm for low power and also control a CPU fan for higher temperature. The inputs and outputs for this circuit are described in the table below. The exact operation is defined in the following truth table. The alarm turning on. The truth table shows the alarm to be on 2 times when C0 and V and T0 or C0 and V and T. This can be simplified using the theorem XY or XY0 is equal to X. X in this case equals C0 and V and Y equals T. Now the equation reads C0 and V since this was X. The fan takes more steps. The fan is on when C0 and V0 and T, or C and V0 and T, or C and V and T. You will create 2 instances of C and V0 and T using the idempotent laws where X or X equals X, making the fan set to C0 and V0 and T, or C and V0 and T, or C and V0 and T, or C and V and T. The simplification theorem again, this time where X equals V0 and T and Y equals C. Now the fan will be on when V0 and T, or C and V0 and T, or C and V and T. The last step in simplifying the fan uses the same simplification theorem, this time X equals C and T when Y equals V. The fan will then be on when V0 and T, or C and T.
In Lab 1, Part 3, we must create a logisim diagram to match the equation that we created for the alarm and the fan. To do this, we have an AND gate for the C0 V with the cord, with an inverter on the cord to get the C0, and then we have the voltage going into that to determine the alarm. For the fan, it's V0 T plus CT, so we have an AND gate with the voltage and the temperature with an inverter on the voltage, and another AND gate with the cord and the temperature going into an OR gate to determine the fan. To test this, we will look at our truth table on the left and then test the different scenarios. So when all 3 are off, the alarm and the fan are off. When all of them are on, the fan is on, but the alarm is off. When the cord is off, then the alarm goes on. At this point, you would test, once you've tested your circuit, you will go into your logisim submit, and then you'll select your file, you'll put your username, and then you'll click on upload. And then at this point, it will go and test your circuit to make sure that everything is good. Once it says everything is good, it's going to tell you all your tests pass, and it's going to give you your part checks and make sure that all your parts are correct. For this lab, the conclusions that we came up with were the hardest part of the lab was the simplification of the Boolean equation. Once we had that, it's a fairly simple operation to actually create the logisim and to test it. And the test is very thorough, and it shows you everything that could be wrong, and you can go back and correct it. That is our lab.